All right, as for Zoom, let me go ahead and say this. Our Zoom time is going to be on Mondays from 10 to 10:30. And we only have Zoom whenever it is in TI days. So whenever we go hybrid, I don't have Zoom anymore. But if you're someone who's going to be going to school online the entire time and you want a Zoom time with me, just reach out to me and we'll see what we can do, okay? So today we have two goals. We're going to know all the properties of exponents, and we're going to use the properties of exponents to simplify expressions to contain only positive exponents. So this is a review again. So here we go. Goal number 1, properties of exponents. All right, so first we have the product rule. The product, which means to multiply, is talking about if we have two exponents that are multiplying, and the key thing is they have to have the same base. So the big letter or the big number has to be the same. So in here, I bet y'all missed that tone, don't you? In here, the things that are the same are that capital A. So our product rule states that when you multiply, you're going to add your exponents. Okay? For example, say we had all right, so first of all, if you notice these 2's in the front, we're going to do what we are going to say, multiply. So 2 times 2 is 4, then we have our x, and then we're going to add our exponents. So we go 2 plus 3 is 5, so that's our new exponent. That is how we do the power rule. Now, power of a product rule. So that means, what if we have two things multiplying and they're both being raised to a power? Now, the way I explain this to my students is I say, well, think of it kind of like a distributive property of multiplication, but it's distributive property with an exponent. We are taking it to everything inside the parentheses. So now we have a to the n, b to the n. Okay, for example, all right, we have 2x squared squared. So that means this square on the outside is going to distribute to everything. Actually, let's get rid of that right there. So that means we would have 2 squared and x squared. Well, then 2 squared is 4. So there's our final answer. Okay? Quotient rule. Quotient means to divide. So let's think about this. When we multiplied, we added. So since multiply and divide are opposite, what's the opposite of addition? Subtraction. So that means we're going to now subtract. So let's do an example. I used the one that we have up here because I wanted to show you all something. Now, if you have numbers, like we have the 2's there, we want to simplify them first. So 2 divided by 2, some of y'all would say it cancels out, creates a 1, it's gone. So now we have 2 and 3. So what I do is I always just subtract the largest from the smallest. So I'm left with a 1. Now, where does it go? Well, it's going to go with your larger 1. So since this is x cubed, it gets to keep it. That also means that everything up here has gone away, leaving us with just a 1 on top. Can't have nothing on top, but you can have a 1. All right, let's keep going. Power of a quotient. So this is whenever you have quotient happening and they're all being raised to the same power. It's just like power of a product rule. We're going to distribute that exponent to everything. All right, let's do an example. All right, we're going to distribute that 2, that square, to everything. So we have 2 squared over x squared, which can simplify to 4 over x squared. Okay, let's keep going. Power to a power rule. So this is whenever you have a power already happening, and we want to raise it to another power. So whenever this happens, you're going to multiply your exponents. So let's do an example. So this would mean actually to take our exponents and multiply them. Well, 2 times 3, 6. If there was a number in front of here, you would also apply this rule and you distribute that cube to the number. We're going to do an example like that later. Negative exponent rule. I'm going to do 2 of them for you. All right, so anytime you have a negative exponent, you have to turn it positive. And the way you do that is by flipping it. So if the negative is on top, we're now going to put it on the bottom. If the negative is on the bottom, we're now going to move it to the top. So this would turn into, ta-da, to make it positive. To make this one positive, we would move it to the top. Ta-da, just like that, okay? Now I don't know if we're looking for an example, but we do one later on. So, all right, and the last rule we have is the 0 power rule, which is the easiest one. It tells us that anything raised to a 0 is 1. So for example, let's say we had 5x to the 8th, y to the 7th, and z to the 12th, all raised to the 0 power. Guess what? Equals 1. Ta-da! All right, now let's do some examples that are going to line up with your homework. So this is goal 2, using the properties. So what I've done is I've taken specific problems from your homework and I've done them in your notes for you. So you have some of your answers already with you, okay? So this is using our product rule. So remember, whenever we are multiplying, we're going to add our exponents. And I know this one doesn't really have a number there, but there's an invisible 1 that exists. So let's start with our base. We have a base of 8x. We can take those 8s and multiply them. So 8 times 8 is 64. Then we have our x. Now we're going to take our powers and we're going to add them. So 4 plus 1 is 5, and that is now our new power. Okay. Now, power of a product rule. Remember, whenever we have outside the parentheses, if we have an exponent, that exponent is going to go to everything inside the parentheses. So technically we have 8 to the 3rd, x to the 3rd. Now that's not the final answer. If you use a calculator or use the one that I suggested, like the app one, you'll see this little rooftop here. So we're going to go 8, hit the rooftop, and then put in a 3rd. And that will give us what 8 to the 3rd is. If you're not comfortable with that, remember an exponent means something being multiplied by itself. So it would be like saying 8 times 8 times 8 3 times. Bing. Okay? So our final answer here would be 512 x to the 3rd. All right. And some of you are all like, how am I going to type that in on Google Forms? It's multiple choice. So you don't have to type anything. All right, let's keep going. Quotient rule. All right, so remember in the quotient rule, we're going to end up subtracting our exponents. And remember when there's not a number there, there's an invisible 1. Let's take care of our big numbers first. 6 over 8. Can that reduce? Yes, it can. 6 over 8 can reduce. They're both divisible by 2. That leaves us 3 over 4. All right, now let's talk about what our m's got going on. We have a 1 and a 3. So we're going to say, okay, 3 minus 1 is 2. Which one's bigger, 1 or 3? 3 is bigger, so that's where it's going to go. And this one's gone away. So here's our final answer. Okay, I know some of you are like, why does that one go away? Because it's subtracted from the 3. That's why it goes away. All right, power of a quotient rule. Again, remember if there's a set of parentheses and there's a power outside of it, that power goes to everything. And I mean everything in there individually. So now we have 2 squared, x squared, y squared. And we can simplify this one. We can simplify the 2 squared. So it is now 4x squared y squared. All right. Example 5, power to a power. Now remember, if it's outside the parentheses, it's going to go to everything. And remember, whenever you do a power like this, you're going to end up multiplying. So this is like saying R2 times 3. Well, what's 2 times 3? It's 6. Okay, let's look at this one here. Because the 3 is not only going to go to the 5, but it's also going to go to the 4, creating that power to a power effect. So what we have now is we have 5 to the 3rd, and then we have p to the 4 times 3. All right, remember how to find out what 5 to the 3rd is? You can use your little rooftop button here. So we go 5 to the 3rd, or if you're not comfortable with that, it's 3 times. 1, 2, 3. 5 times 5 times 5. So we have 125 p, and then we do 4 times 3, which is 12. All right, let's keep going. Negative exponents. Now remember, the way we turn it positive is we flip it. If it's already on top, we're going to move it to the bottom. If it's on the bottom, we're going to move it to the top. So whenever there's nothing written like this, so that's how we turn it into a fraction. So right now, 7x to the 4th, it's fine where it's at. It doesn't have to change. It's already positive. But we have y to the negative 4th, so we need to change it by putting it on the bottom. Once it goes to the bottom, it is now positive. 2 more examples and then we're done. Okay, now, anything raised to a 0 power equals what? It equals 1. So even though we have all that going on in there, because of that 0, it's equal to 1. All right, I wanted to do one really difficult one. This one is not on your homework, but I wanted us to talk about it, okay? All right, so what we have going on in here is we have negative 2 n to the 0. So the first thing I notice, if there's an n to the 0, that means this is turning into a 1. So it doesn't matter anymore. So then we have minus 2n to the negative 4th, all raised to that negative 4. So what I'm going to do is I'm going to go ahead and move this power to everything. So what that gives me now is I have negative 2 to the negative 4th minus 2 to the negative 4th in power to a power, negative 4 times negative 4, all over negative 3 to the negative 3. I know, it's a lot of negatives going on, right? So here's what I want to do. Let's go ahead and simplify this right here. Because a negative times a negative makes a positive. 4 times 4 is 16. So now n to the 16th is on top. It is positive. Okay, now look at our negatives. Here's our negatives. We have all this that is negative. The way we make that positive is we need to move it to the bottom. So we have negative 2 to the positive 4 minus 2 to the positive 4. All right, we also have a negative right here that we need to turn positive. So now we have minus n to the positive 3. And some of you are like, wait a minute. I'm confused. I thought you said this turned it positive. It doesn't turn the numbers positive. It turns the exponents positive. All right, so a lot of you are like, okay, well, 16 minus 3 is 13. Remember, if this was multiplication, we could do that. We can't do anything else with that. That is in simplest form. So n to the 16th minus n to the 3rd on top, divided by, all right, now let's talk about this. Let's see what happens. So we have negative 2 to the 4th minus, actually, just leave the negative out. So 2 to the 4th is 16, minus 2 to the 4th, which is 16. Well, that gives us what? Negative 32. Voila. Will you have questions like that? No, not until next year. But I still wanted y'all to see just how